So quantitative PCR is a method in which a segment of DNA is not only amplified, but it's also quantified at the same time. Sometimes we call this technique real-time PCR because the DNA is quantified in real time at the same time it's being amplified. The technique starts just like regular PCR. We make a mixture of template DNA, of nucleotide triphosphates, those are the building blocks of DNA, a buffer, a primer, and a polymerase, which is the enzyme that carries out the reaction. We mix it, put it in a tube, and put it in the machine. And then we run a cycle. And first we're going to heat the DNA, and by adding heat we're going to separate the strands of DNA. And then the temperature is cooled a little bit so that our primers can stick or anneal to the DNA. And then we bump the temperature up just a tiny bit, and that is when the polymerase takes over and adds the building blocks to the new strands. We're going to do this 35 times or so, and the amount of DNA should double at each cycle as long as we don't run out of reagents. When you're doing regular PCR, it's difficult, if not impossible, to determine which reaction started with more DNA. Different amounts of starting template can produce similar amounts of product due to the limiting effect of the reagents. Simply, we're running out of the reagents. This image shows a typical PCR product displayed on an agarose gel. And in this case, the DNA template was diluted tenfold prior to each reaction. And after enough dilution, you can see some variation in the intensity of product. But for some dilutions, though, the bands are just too similar. You can't tell which material you started with. In quantitative PCR, a spectrophotometer and a fluorophore are used to quantify the DNA. At the end of each cycle, the fluorescence is measured, allowing the DNA to be quantified. We commonly use cybergreen as our fluorophore, as it only fluoresces when the DNA is double-stranded. In other words, the fluorescence should double with each cycle where the amount of DNA doubles. Here we show the curves produced from the DNA samples used before, but this time quantitative PCR was used. We can determine the relative amounts of DNA at the start by looking at which cycles were able to have an exponential increase of DNA. Those that do not have run out of reagents. Here the most dilute DNA sample is on the right, and the most concentrated DNA sample is on the left. We can tell with certainty which sample contained the most template DNA at the start of the reaction. The technique can be used to quantify DNA and can even be used to look at gene expression by studying RNA amounts. It's a simple yet elegant technique that allows us to gather a great deal of information about our DNA and RNA samples as well as the cells from which they came.